Title of the experiment is Crystal Oscillator. Aim to build and test crystal oscillator. Apparatus, resistance boxes, CRO, DC power supply, capacitors, transistor, and so on. Now it is a particular circuit diagram. It is the crystal connected between base terminal of the transistor and that of the ground terminal of the whole circuit. It is NPN type of transistor. Collector is connected in between this resistance R2 and that of the VC power plus VCC, that is the power supply. Again, it is connected to the capacitor C1, it is capacitor C2, and this C2 is connected to the another terminal of the crystal and ground. Now remaining is their emitter terminal. To this emitter terminal, the resistance RE is used. It is near about 1 kilo ohm, and this CE capacitor is connected across this emitter terminal. Now across this capacitor CE and that of the ground, we can use the CRO plate, or one can connect the CRO plate. This crystal 1 terminal, base through R2 and collector all are connected to the plus terminal of the DC battery, and this ground is connected to the minus or negative terminal of the DC supply. Here we need DC supply. Now one question is that what do you mean by crystal oscillator? Oscillator is one important basic circuit in the electronics. Oscillator, it is not compared to the ordinary, that is oscillator in general physics. It is somewhat different, that is oscillator is different in general physics, whereas oscillator is having different function and meaning in the branch of physics as electronics. Now oscillator is an electronic circuit which results the output without giving any input. It is the basic definition of oscillator. Now regarding the oscillator, there are different types of oscillators such as Colpitt's oscillator, phase shift oscillator, Hartley oscillator, crystal oscillator, and so on. The basic theme or the idea is same behind each oscillator, that is oscillator is an electronic circuit which results the output without giving any input, that is known as oscillator. Now for this particular crystal oscillator, we can measure the frequency of the oscillator by using this formula. F equal to frequency F is equal to 1 upon 2 pi square root of RC. R is the resistance, C is the capacitance of the capacitor. Now this R is here we are using, and this C here, both capacitors C1 and C2 are of equal value, and therefore here we have to calculate the equivalence capacitance, means C1 upon C1 by using the values of this C1 and C2 we have to calculate the equivalent capacitance. Now observation as F is equal to 0.5 10 to 6 Hertz, means 0.5 megahertz. Now observed frequency of the crystal is period T is equal to number of divisions into time per division, that is 0.4 into 5 into 10 to minus 6. Therefore period comes out to be 2 into 10 to minus 6, because it is in terms of division and this reading is in terms of time per division. Therefore this denominator division and this numerator division gets cancelled, and it is in terms of time, and that is why it is periodic time, or period T of the resultant waveform on the CRO screen is 2 into 10 to minus 6 second, and its time period reciprocal is nothing but the frequency. Therefore it is 0.5 into 10 to plus 6 Hertz. To the denominator it is minus 6, when we are taking its reciprocal comes to the numerator and the power becomes positive, and therefore 0.5 into 10 to 6 Hertz. Therefore frequency F is equal to 0.5 megahertz. Therefore observed frequency of given oscillator in terms of Hertz is 0.5 10 to 6, and in terms of megahertz frequency is equal to 0.5 megahertz. Whenever you are writing the result of any experiment in the physics, you have to represent that result in terms of its particular unit. Generally we are using in each case the CGS unit of the each quantity. Maybe in electronics, maybe in physics, maybe other branch, optics or whatever it may be. Generally for producing the results we are using the CGS method for CGS units for writing the units. Now on the CRO screen, actually sinusoidal waveform is formed, and this sinusoidal waveform we have to measure the lambda wavelength of the wave multiplied by the corresponding time period. Therefore, capital T is equal to lambda into small t, and hence the frequency is equal to 1 upon capital T. It is about this crystal oscillator experiment. Now the question here remains is how one can face this practical for the online examination. While performing this practical and facing this practical for the online practical examination, you should produce, there are some questions we have to face. That is, what is oscillator, what is crystal, what type of is crystal, that crystal is of piezoelectric type of crystal. Therefore, what do you mean by what is the type of the crystal? What do you mean by oscillator? What are the different types of oscillators? What is wavelength? What is time period? And what is frequency? And what are their units? These are the some possible oral questions for facing this practical.